So I'm going to rewrite this series a little bit to make it a little more accessible. When we first looked at this series right here, that was our basic power series, and we used an R. And we went from 0, n goes from 0 to infinity. All right, so what does that look like? It's 1 plus r squared, and you just keep going with powers of r. And we found that if r in absolute value is less than 1, then this converged to 1 over 1 minus r. All right, so it's just the same idea they're throwing an x in there instead. So it's just our basic geometric series. So it turns out we can use that to build series for other functions. So what I want to do is I want to relate this function to that function. So they just differ in the denominator. So I just need to figure out what I should do for r here. So I'm just going to take my 1 minus r, set it equal to 9 minus x, and I'm going to solve for r. So I'm going to subtract 1 to the other side. So I get 8 minus x. And then I'm going to take the opposite of each side. So r equals x minus 8. So if I drop an x minus 8 in for the r, then that's going to give me this right here, which means I got to do the same thing for this up here. Okay, what about the center at 6? So we'll think about that in a second. So in this series here, then I'm going to have 1 over 1 minus, and I'm dropping in the x minus 8. And when we clean that up, we're going to get a negative x. We're going to get a negative negative 8 plus 1 is 9. So that is 1 over 9 minus x. But I've set up for a substitution in here. So that's going to be equal to, just replace that r with an x minus 8 to the end. And then n goes from 0 to infinity. So this is the series for 1 over 9 minus x. And the radius of convergence that we grabbed for this is related to the one we started with, but we replaced the r with an x minus 8. So as far as establishing that radius and interval, we now have the absolute value of x minus 8 is less than 1. We don't know what's going on at the endpoint yet. So that gives us our series. Next, we got to think about, all right, how do I deal with the center at 6? So let's figure that out. What does this mean? So this says the distance between x and 8 has to be less than 1. So that gives us an interval with 8 in the middle. And we can go 1 to the right up to 9, or we could go 1 to the left, and that would be a 7. So that's what this sets up there. I don't know what's going on at the endpoints yet. We'll check those in a minute. So this series I found is centered at 8. And I want to center this at 6. Okay, what do we do to center it at 6? Good question. Now we can't just do a substitution to shift this over, because that will change the series for this here. But if we call this sucker right here f of x, this series is also a version of f of x. Shit, I don't have an easy way to do this off the top of my head. Seems like this question belongs in section 6.4, where there is a technique to shift it like that. Oh, let's just try something. So if I call this f of x right here, we want to shift the function so it's not centered at 8, it's shifted at 6. So that means I want to shift it to the left. Function-wise, if I replace x with x plus 2, that should be a shift left 2 units. So then that would change this series up here. That would give me the sum as n goes from 0 to infinity. And I'm replacing the x there with an x plus 2. The x minus 8 is still chilling out there. X plus 2 minus 8 simplifies to x minus 6. So this series is now centered at 6. but it's not the same function as this one anymore, because again, we shifted it over 2 units. So that seems like it shouldn't be an acceptable answer. Let's see what the homework was looking for there. So my first guess is x minus 6 raised to the power n. Yeah, and that is not a correct way to do it. So based on what we've done so far in section 6.1, I don't remember any technique in there to do this. I can show you a new technique that's not in this section. Well, it's in section 6.4, which I wanted to start today, but somehow this question ended up in the 6.1 homework. So I was assuming there was a way to do it with techniques from 6.1. And I don't see anything similar. Oh, okay. All right. So it turns out in the body of the book, there's no technique, but they give a hint here on how to do it. So now I see how to do it. Okay. I'll explain the hint.
You have to account for the center on the original function.
Yeah, so we can't do that right there. But what is true is that this is definitely a power series for that. So if we graph the first few terms of this right here, it'll look like that near x equals 8. Okay. We want it to look like this function near x equals 6. So then rewriting this, okay, so I need a new page to do this. This is getting messy. I see it. All right. So we got to incorporate the center first before we do anything. So what I really want, let's see, this to be here is I need this to look like a minus x minus 6. That will give me the center at 6 I want. I just got to figure out what goes over there to compensate. So let's see, if we do that, that's going to be a minus x plus 6. And over here, I have a 9. So then there should be a 3 out there to compensate. All right, because 3 plus 6 would give me that 9 up front. So I want to rewrite this right here as 1 over 3 minus x minus 6. Okay, next. The 3 here is a slight problem because this has a 1 there. All right, so what am I going to do about that? I'm going to divide everything by 3. So now I've got the 1 over 9 minus x is 1/3 over 1 minus parentheses x minus 6 over 3. And I had mentioned last class and earlier before the recording that at this point we have like 4 ways to mess with this basic geometric series. We can substitute in something in place of x. We can differentiate the series. We can integrate the series, or we can multiply or divide by something. So what I have here then is a substitution. So we're going to substitute that in place of this x here, and then we're going to multiply the whole thing by 1/3. Okay, so pulling that off, rewriting this right here to match the 1/3 over 1 minus x minus 6 over 3. We're going to get a 1/3 times the sum as n goes from 0 to infinity. And instead of just an x to the power n, right, we're doing this substitution here, x minus 6 over 3. So this is my new power series now. And what we should find is if we graph the first few terms of this and we graph that, they'll match up near x equals 6. Next, we need to find the radius. There's two ways to find the radius of convergence. We could use the fact that we did a substitution. So originally we had the absolute value of x is less than 1, but we replaced that x with that. So now we have the absolute value of x minus 6 over 3 is less than 1. The alternative to doing that is to use the ratio test on this right here. So you could apply the ratio test that'll accomplish the same goal. The alternative, use the ratio test. All right, cleaning this up right here, I can multiply both sides by 3. So I get x minus 6, an absolute value is less than 3. And so what this says is x can be any number that its distance from 6 has to be less than 3. So interval-wise, that puts 6 in the middle. We could go up to 9 on that side and as low as 3 on that side. What we don't know, so any x value in here will have convergence, but we don't know the endpoints. The ratio test doesn't tell us about the endpoints. So we needed a different test to test the endpoints. So what's the radius of convergence for the series?
3.
3, yeah, the distance from the endpoint. So right now we know the radius is 3. And I think this question next asks, well, what's happening at each endpoint? So I need to then test the endpoints. So test x equals 3. And if we plug in 3 to that series, we're going to get 1/3 times the sum as n goes from 0 to infinity of 3 minus 6 over 3 to the n. 3 minus 6 is -3, over 3 is -1. So this would be 1/3 times the sum of -1 to the n, which is 1/3 times, let's see, we're starting off with 0 to infinity. So 1 minus 1, plus 1 minus 1, plus 1 minus 1, forever. So the first partial sum is 1/3, the next partial sum is 0. The next partial sum is 1/3, the next partial sum is 0. It's going to keep bouncing forth between those. That's divergent. If we test the other endpoint, x equals 9, then we get 1/3 sum of 9 minus 6 over 3 to the n, which is 3 over 3 or 1 to the n. So that would be the sum 1/3 times the sum of a bunch of 1s from 0 to infinity. What's this doing? Oops, it's the one there. Definitely diverging. It's making it bigger and bigger and bigger and bigger. Okay, so it diverges at each endpoint. So now this is definitely, we know for sure, those are open circles at the endpoints. It diverges there at the endpoints, but converges inside. So back here, I've got 1/3 times parentheses fraction x minus 6 over 3 raised to the power n is my series. And the series is convergent from, let's see, low was 3 and the high was 9 for mine. And is the left endpoint included? The answer is N for no. Is the right endpoint included? The answer is N for no. And it varies from series to series. That was a tricky one. Okay, something important about these. There's a lot of different ways to look at them. They can be pretty hard. Expect to not get it right the first try. That's okay. Try something else. It is natural to get these wrong first try.